Hey guys, and welcome back. This is going to be a quick video introducing the intermediate value theorem for polynomials. So let's go. Hey guys, and welcome back. This is going to be that video about the intermediate value theorem. And so without further ado, if f is a polynomial function with real coefficient and f of a and f of b have opposite sign, then there is at least one value c between a and b so that f of c is equal to 0. Basically saying that if you get two values of x and you happen to find their y value by plugging them into the function, if their y value happens to have different sign, one is positive and the other one is negative, then between a and b, the function has to go through the x-axis. So there has to be a number c so that f of c is equal to 0. And so this is a theorem. It is a mathematical statement that has been proven to be true. So you can add it in your back pocket and use it whenever you want to prove that there is at least one zero between an interval given to you. So on a graph, maybe this will make more sense. So if I have the xy plane here, and I draw a smooth function because polynomials happens to be smooth, you can see here that if you have a point x equals a here, with its y coordinate down here, f of a, happening to be negative, and you have the point x equals b here, with its y coordinate up here, f of b, happening to be positive, then you can clearly see that if a and b happens to have opposite sign, like they do in this picture, there has to be a place between a and b where the graph has to go through the x-axis. And that's basically what this theorem is saying. And so let me give you some example questions that you could be asked to prove. The first one is going to be for us to prove that the function f of x equals to x cubed minus x minus 1 takes the value 0 somewhere between x equals 1 and x equals 2. And so to do this, you can go ahead and say, oh, I'm just going to set the function f of x equals to 0 and find out what my x-intercepts are. And if there's one falling in between 1 and 2, then I'm done. But that could be hard to do because this function is not easy to factor. And so an alternative to that would be to use this theorem because we know it's true and just go on with your day. And so we're going to have here that f of 1 is equal to 1 cubed minus 1 minus 1. That's equal to negative 1. So this happens to be negative. And we're going to have f of 2 equal to 2 to the power of 3 minus 2 minus 1. And that's going to be equal to 5. And that's positive. And so because this is a polynomial and f of 1 and f of 2 happen to have different sign, you can say that by the intermediate value theorem, there is in fact a c in between x equals 1 and x equals 2, such that f of c is equal to 0, right? So you're not asked to find the c value. That's another problem. You just asked to prove that there is a c in between x equals 1 and x equals 2. And so this would do it. Here's another example. Let's say you're asked to show that the function g of x equals to 2x to the power of 4 minus 4x squared plus 1 takes the value 0 somewhere between x equals to negative 1 and x equals to 0. You go ahead and do the same thing that we did before because again, if you set this function equal to 0, it will be hard to solve because you cannot actually factor this easily. And so if you go ahead and figure out what g of negative 1 is, that's going to be 2 times negative 1 in parentheses raised to the power of 4 minus 4 in parentheses negative 1 raised to the power of 2 plus 1. And so if you add this up together, you will get that this is equal to negative 1, which happens to be a negative number. And g of 0 is equal to 2 times 0 to the power of 4 minus 4 times 0 to the power of 2 plus 1. And that should give you 1, which happens to be positive. And so again, you can say that by the intermediate value theorem. Remember, you have to call this term every time you use this technique because that's the term that's been proven. So by the intermediate value theorem, there exists a c between x equals to negative 1 and x equals to 0, such that f of c is equal to 0. And so with that, you're done. And so now, other than finding the actual value of c by setting the function equal to 0, by finding the x-intercept, There are other methods that can be used to find a good approximation for this value of c, especially when the function f of x equals 0 is hard to solve, which is most of the time. And so in my future videos, I'm going to cover some of these methods. But until then, if you like a copy of this particular note, check out the description below. And if you like the way I break down the material, give me a thumbs up, and I'll see you in my next video. Bye-bye.